Hello, everyone. A very good afternoon to all. Dear authors and invited guests, welcome to Technical Session 11B. My name is Anisha, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 17th of July in Goa, India, and the virtual event is being held through Zoom from 17th to 19th July 2025. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. So in this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. And on 9 minutes, I'll raise a gentle reminder. There's another request to all the participants to please stay connected with us till the closing of the session. And if you have any query or update, then you can write it to me in the chat box. So before we start the session, I'd like to introduce you all to the chair for this session, Dr. Vaishali Rajput. Dr. Vaishali Rajput is an assistant professor in the Department of Artificial Intelligence and Data Science at Vishwakarma Institute of Technology, India, with over 20 years of academic experience. Her expertise lies in the field of AI and data science, and she's an active professional member of the Society of Data Science. We welcome you to the session, ma'am. Would you like to give an opening remarks to all the participants before we begin with the presentations?
Yes, ma'am, sure. Am I audible?
Yes, ma'am, you're audible.
Yeah, okay. Respected team, organizers, fellow researchers, and dear participants, it is a great honor to join you today as a session chair at this conference. This platform truly reflects the spirit of innovation and collaboration in the field of technology and communication technology for sustainable development. As all of us gather here, I would like to give you a reminder that ICT is not just a technology. It is not about a technology, but it is about connecting people, empowering communities, and creating solutions that make a real difference in society. So let us use this opportunity to share your knowledge, inspire new ideas, and work together towards a more inclusive and sustainable future. Thank you, and I look forward for the insightful and interesting sessions and discussions ahead.
Thank you so much for your remark, ma'am. Now we'll begin with the papers. And our first presenter is Madan Kumar Sharma with the paper title A New Composite Structured CSRR Loaded Multi-Resonating Sensor for Mining-Based Material Characterization. Sir Madan, if you're here in the session, you may please start with your presentation.
Yes. Good morning, respected session chair and organizing of ICT4SD conference team. It's my great pleasure to present my research on this platform. So now I am sharing my presentation so that you can take a look of that. I hope my screen is visible to everyone. Yes, please.
Yes,
Ma'am,
it's
my screen.
visible.
Yeah. This is my research paper, which is accepted here in ICT4SD, a new composite structure CSRR loaded multi-resonating sensor for mining-based material characterization. So this paper basically developed a sensor which is experimented with the mining-based material. This is the table of contents. I would like to cover abstract, research gap, identify major contribution, design and development of the sensor, electric field and surface current distribution analysis, mining based material characterizing using the proposed sensor, and conclusion. This is the abstract. Actually, we developed a multi-resonating microwave sensor, which emerging technology for in the field of sensors. And basically, it is designed for mining-based material characterization uh, due to the high sensitivity and precision. This research presented the novel microwave sensor for mineral-based material characterization. The sensor basically resonating structure comprises by the circular shape complementary split ring resonator 3 by 3 array, and there is a surrounding of this array. There is a defective ground structure uh, of the certain of the rectangular shape, and this configuration enhances the electromagnetic interaction with the material under test and leading to the precise characterizing based of the S parameter analysis. To validate the sensor efficiency, simulation-based investigation were conducted on mining-based material, including the chrome, copper, and quartz. The obtained result demonstrate the distinct resonance shift for the the different material. They show the resonance shift, and it shows the highlight the capability of analyze the dielectric properties of the material. So the proposed sensor design provide a robust and efficient method for non-destructive material characterization, offering potential applications in the mining industry and quality control and geophysical exploration. This is the research gap identified. Basically, the existing technology in the field of mineral identification and characterization. The most popular technologies are available XRD, XRF, and SEM, which is more expensive and laboratory-based analysis. Basically, micro sensing can provide the alternative solutions, which is low cost and portable on-site measurement capability over these well-established detection technologies. So multi-resonating sensor have emerged a powerful tool for mining-based material characterization, offering the high sensitivity, non-destructive measurement capability and rapid response time. Many times the material testing by XRD, XRF, there are, depending on the sample preparation also, the sample, if it is not prepared well, the reflection of the rays of X-rays in diffraction and another machine XRF, in both cases, the exact detection could not be possible. So material nature of the preparation of sample require the non-destructive. But in case of microwave resonator sensor, it is not such of the characteristics of the sample preparations required. So these sensors are operate on multiple resonate frequencies to analyze the electromagnetic property of material such as permittivity and conductivity. The major contribution of this work to develop a composite shape structure uh, complementary split ring resonator sensor for material characterization, test the sensor performance in terms of S parameter, current distribution, and the other performance indicators. Furthermore, the samples of the copper, chrome, and silica mimic into the CST environment and tested by the this sensor. This is the proposed design of the sensor. Sensor is developed on the overall size of substrate of 100 by 60 mm of the FR4 with the dielectric constant of 4.3. And this structure is basically having 3 by 3 circular CSRR array here. And adjacent of this array, there is a rectangular DGS structures are created surrounding 4 structures. And this is a 2-port device actually here. So the structure comprises with the top layer, substrate, and the ground. Ground is fully covered by the copper metal. The sensing area is designed using the ring resonator. This is the sensing area of the sensor. So basically, the effect of this sensing area we can see into the further slides. This is the graph which indicates the resonating behavior of the sensor. So S parameter indicates here, which is S11 is indicate the red color. So there are many resonating peaks are achieved 1, 2, 3, 4. 4 peaks of the resonating of S11 achieve in the sensor, as well as S21 is have a sharp peak at around the 1.5 gigahertz, which is a very important parameter in the two-port network, which is known as the transmission coefficient. It is a good resonance peak is achieved in the S21 parameters. This is the electric field and surface current distribution. The electric field and surface current are very important, which show the resonating behavior of the sensor. So how the field is interact when the signal is given to the sensor, and it is majority of the distributions you can see here in the picture. The maximum field is surrounding to the resonating array, CSRR array. Maximum field is achieved here. So this is a sensing area, and surface current distribution also indicates that is surrounding to the CSRR structures. So the basically the at the resonating frequency 1.1 and 1.9 gigahertz, these results are indicates that the sensing area of this sensor is totally surrounding by the array. Next step, once the sensor performance is achieved, the mining based material characterization take place. So we have mimicked the equivalent dielectric property of the ore of the copper, chrome and silica, which is quartz ore. We taken the dielectric approximately of that ore dielectric properties. Even though copper is a conductive material, which has the very high in practice, in ideal case infinite, the dielectric constant, but we would like to know the what is the exactly sensor behavior has changed when interact the conductive material also. So that's why we get a some of the resonating change in the case of the copper. However, the quartz silica having the approximately 3.7 to 4.6 dielectric constant, which is the ore, and another is chrome. Chrome is having the around 7 to 8 dielectric constant. So basically, dielectric constant play very important role while interacting with the electromagnetic waves radiating signal by the sensor. So that's why we are talking here dielectric constant. So the material under test is placed over the sensing area, and the signal is fed by the port 1, and we see the results across the port 2, which is known as transmission coefficient, how it is behaved while the material interact with the sensor. So we taken the sample of material 20 mm dia with 2 mm thickness, and we place over the sensing area of the sensor. In case of the chrome results are indicate here, which is reflection and transmission results. We found the resonating shift of the S11 values, which is around to the 10.22 dB with the resonating shift in the frequency of 0.16 gigahertz. However, the transmission coefficient has been shift from the frequency 1.5 gigahertz to the 1.48 gigahertz. So this is an indication of the material which can be sensed by the proposed sensor. The same way of the copper case, as I already has mentioned this point. The copper case, the dielectric infinite, so it's a pure conductive material. So maximum energy stored into the material. So the reflection is, totally has changed in case of the copper material. However, the resonating shift is take place 1.3 gigahertz and 1.1 gigahertz with the peak values of 18.87 dB and minus 21.2 27 dB respectively. However, transmission coefficient indicates here the shift from the at the frequency 1.49 gigahertz with the value of the transmission coefficient value minus 33.8 dB. Another is a quartz material. Quartz material has given the shift in the resonate frequency for S11 and the S21 case in the both cases also. So this is by the way the material characterization take place. Uh, Due to the short of time, I have not included the more detail of the tables which indicates the exact values of the resonating shift and the magnitude of the shift or standard deviation of the values. I have not included here. This is a conclusion of this sensor. In this study, multi-resonating sensor was successfully implemented. Sensor designed with a circular shape a CSRR array, which exhibits the multiple resonating points at the frequency of 1.1 gigahertz, 1.4 gigahertz, 1.61 gigahertz, and the 1.91 gigahertz. The sensor's resonate behavior was further analyzed through the evaluation of electric field distribution and current density. Additionally, the transmission coefficient demonstrates a resonate shift resonate value of 1.5 gigahertz with the corresponding value of 74.45 dB. Furthermore, the sensor has analyzed three materials which show the resonating shift for the chrome 0.16 gigahertz with the peak deviation in the value of reflection coefficient 10.22 dB. For the copper, maximum resonate shift is 0.31 gigahertz with a peak of a deviation of S11 value 1.87 dB, while quartz display maximum resonating shift of the frequency 0.11 gigahertz at the fourth resonating point with the peak deviation of 4.78 dB. The sensor's multi-resonating characteristics make it highly suitable for analysis of various material, particularly those with sensitivity with different frequency range. So this is the conclusion of this proposed work, and these are the references. Uh, Thank you very much for this opportunity to present this work. If any query, please take the now questions.
Thank you for your presentation, sir. Do we have any questions?
Thank you, sir. Thank you so
yeah.
much.
Hello.
Yes, ma'am. Yes, ma'am,
Yes,
please.
this presentation was really good. I just want to ask you one question that can you elaborate on why the sensor shows multiple resonant points and how these points would help in material characterization?
Yes, ma'am. Actually, the case of multi-resonating, actually, resonance is just like a peak we achieve at the certain frequency in the sensor. The existing solution, the many sensors have a single resonating points, but sometimes the single resonating analysis might be, not give a exact, the shift. So multi-resonating give us the more opportunity to demonstrate the change of the material properties. So that's why the multi-resonating behavior is more desirable compared to the single resonating behavior.
Yeah, okay. And you have tested different materials like chrome, copper, quartz, like that. So,
Yes, ma'am.
what do you think that cord displayed the highest peak deviation that you have given as S11, despite it is having the smaller resonance shift?
Yeah. Actually, the case is if we are moving towards the material with the high dielectric, that shift might be not appear because the electromagnetic wave when interact, the dielectric properties are play major role. So that's why in a case of copper and chrome, these are the metallic materials, so that cannot be give a such of shift. But is a quartz is almost is a dielectric very low, which is around 3.7 to 4.6. So that's why we get a good resonating shift in this case. Uh, this study furthermore the tested by experimental analysis, and in future work, ma'am, we are going to apply the machine learning so that we can conclude with the exact results analysis.
Yeah. Okay. Okay. Nice presentation. All the best.
Thank you for your presentation, sir. Now moving
Yeah.
on to our next presenter, I would
Okay,
like to
sir. Thank
call
you.
upon Ma'am Geetu Lakshmi to present her paper on the title An Approach for Lung Cancer Detection Using Optimization Enables Squeeze Inception V3 Model. Do we have you here with us, ma'am?
Yes, sir.
Do we have anyone else from the team with us?
Hello, sir. Am I audible?
Yes, ma'am, you're audible. You may present your screen.
Yes, sir. Can you see my presentation, sir?
No, ma'am.
Now, sir.
Yes, ma'am, the screen is visible.
Okay. Good afternoon, everyone. My topic is an approach for lung cancer using optimization enabled skew inception V3 model. And my name is Geetu Lakshmi ji. I'm the research scholar of Kalaslingam Academy of Research and Education, and my guide's name is P. Chinnaswamy. And my agenda is overview of lung cancer, challenges and issues in lung cancer detection, research motivation, objective, related works, summary of the survey, proposed methodology, conclusion, future work, and references. So let's start with lung cancer. As we all know, from 2020, we have affected by corona all over the world, and the lung cancer. That is why I selected the organ lung for my research. So lung cancer is one of the deadliest disease globally due to high mortality and late stage detection. And usually in lung cancer detection, we use X-rays or CT scan for the detection of some irregularity in lungs. And usually tumors are of two types, malignant and benign. And there are three carcinomas, three types of cancers are there in lungs, and adenocarcinoma, squamous cell carcinoma, and large cell carcinoma. Adenocarcinoma is the most common type, often found in non-smokers and outer regions. Squamous cell carcinoma means central airways, it will get affected. Large cell carcinoma means its lungs spreads rapidly, and it usually affects the inner region of the lungs. And let's see a diagram of three cancers. Adenocarcinoma, squamous cell carcinoma, and large cell carcinoma. In my work, I just classified the whether the lung cancer or lung is normal or abnormal. And so the coming to the research motivation, there are manual diagnosis method. Of course, there are other methods also, but there are systems for identifying the cancer. There are different machine learning models, there are deep learning models, and I have gone through some papers and I have identified that there are some methods using CNN, SNN, RetinaNet, and all. While using CNN, demonstrate high performance but did not improve the model's clarity and comprehensibility. And additionally, SNN also employed did not enhance classification accuracy. There is potential to further strengthen the model robustness. And I have gone through a paper which they have used RetinaNet method, but small tumors they have found very difficult to identify the small tumors. And in CNN, also lack of visual analysis of learned feature represented by CNN obstructs the timely evaluation expectation of CAT. The time complexity also affected the CNN. So an efficient deep learning approach is employed in my research work. And my research objective is to develop an optimization-enabled skews inception V3 model for detecting lung cancer. And going through my research, related works, I have gone through 1 to 5 papers, and in my first paper, that is, I have gone through a paper called Lung FNet, Lung Cancer Classification using Efficient Net from CT scan images, and there that was a transfer learning approach using Efficient Net D1 on the IQ, OTH, or NCCD dataset, and it addressed class imbalance with augmentation, but I have found that there is no meta-heuristic end-to-end model, and it's a lightweight and scalable CNN. It has less interpretable feature space, may overfit small data also. And next paper I have gone through was lung cancer detection CT scan using modified density with feature selection methods and ML classifier. And there they focus more on generalization and interpretability via traditional ML classifiers, emphasize robust feature selection compared to deep poly methods. They have used the density methods, and they have also, of course, they have used pre-processing method. Then also the feature selection or the classification was not proper. And third paper was novel deep learning architecture for lung cancer detection and diagnosis from computed tomography image analysis. And there also tailored CNN for nodule classification with high-end pre-processing, like comparison with the advanced DL backbones like EfficientNet or Dense when compared. It was not best. And fourth paper, I have gone through lung RetinaNet, applied RetinaNet with multi-scale feature fusion and contextual information synthesis for effective localization and detection. There also they are outperformed since small tumors are very difficult to identify by the lung retina net method. Then I have gone through LungGAN, unsupervised representation learning for lung disease classification using chest CT and X-ray images. And their unlabeled scenarios when compared, they are not giving a better result when compared to the other methods. And so have summarized that lung FNet provides high accuracy and effectiveness, but fails to optimize efficiency and generalization across diverse data sets. CNN offers improved feature selection accuracy, however, it may face challenges with noisy data and large data set. Also, they have faced some time complexity also. Time was more when classifying the cancers or whether it is normal or abnormal. In RetinaNet also means computation cost is very high, and also small tumors are very difficult for RetinaNet to identify. And my sub-objectives are on developing a hybrid DL method based on optimization for lung cancer detection and SMA-based skews inception V3. The final step involves classifying lung image into two categories, normal and abnormal. So we are going to propose methodology. Propose methodology means first I have taken the lung CT images, and I have done image pre-processing on this lung CT images, and after that I have extracted the feature has been extracted using CNN. Along with that, optimization method is also used to avoid overfitting, and I fine-tuned the parameters and extracted the features, and after that, it is given to the SKUSNet Inception V3 model. And again, there also SMA is given, or optimization method is applied to this classifier, and it has classified as normal or abnormal. Um, let's see the architecture of this proposed methodology. Here, there is city image as the input, and we can see here the reprocessing. Pre-processing also we can see their color space conversion, data augmentation, resizing and normalization have been done. Then a CNN is applied for the feature extraction. Next is SMA based hybrid skews inception V3 is used here. And here I am applied SMA here also to the classifier to classify the lungs into normal and abnormal. And here we can see different steps: convolution layer followed by 9 fire modules. After the softmax is applied, and output is taken, combining with the inception V3 and classifiers normal and abnormal. And for the pre-processing, first pre-processing technique I'm using is color space conversion. Since we can see that it is a CT scan image of lung, so we have to map it onto YCBR CR color space, and for that I using color space conversion to identify the lung is normal or abnormal. We have to map it onto YCBR CBR, YCB CR color space. And after that, data augmentation is used, and I have to double the CT scan images by using horizontal flip, vertical flip, and 90-degree rotation. I have doubled out. I mean, I have 1,000 images, and I have after augmentation, I have got 7,007 images after augmentation, and I have done resizing and normalizing. Resizing and normalizing is to standardize the image so that the classification or feature extraction will be more exact. Next is feature extraction using SMA CNN. CNN have been employed in so much of papers, so many papers. But SMA optimization I haven't seen any paper which have applied SMA to CNN. Only one paper I have seen, and redo activation function is used here. You can see that there is an input layer, there's convolution 2 layers, and flatten and dense layer. And here we have batch size is 1, and we have using 32 filters and 222 feature maps. Again, it is transferred to next convolution layer, and just this in the output layer we can see the different features extracted from the output layer. So
This is
features
a
we got.
gentle reminder that 9 minutes have been completed.
Okay. Just this SMA. SMA means that what does SMA means? We have to locate the different lung color. So for that, we are using the SMA method here. And my novel idea I'm going to explain is that SKUSNet inception. Here we are also using an SMA. SMA is used in this SKUSNet and inception VT. SMA means to optimize the optimize features, and thus we classify it is into normal and abnormal. And these are my results. I have used this confusion matrix, and then ROC curve, and bar, this chart, and also this diagram for um, uh, verifying my accuracy, sensitivity, and specificity, and identified that our method is performing better when compared to the hybrid SKUSNet inception with, which is also my paper, but I have applied SMA, and the accuracy, sensitivity, and specificity have improved a lot when compared to this the previous method. And the summarized way is that I have applied the SMA, and I have noted that the result have been improved a lot. And a hybrid optimization method can also be applied so that the result may get improved. And these are my references. I have referred over 28 papers. Thank you.
Thank you for your presentation, ma'am. Do you have any questions?
Yes, ma'am. Your work is really good.
Thank you, ma'am.
One question from my side. You said that you have selected ReLU function.
Yes, ma'am.
So why you have chosen that function? Like many activation functions are available. For example, sigmoid or tan-h like this. So what is the reason for selecting this particular function?
Which is that means that if there are values under 0, that means if there are values under 0, we have to avoid that pixels from this particular image. So for that, ReLU have been identified. Other methods also have employed, but it has been found that the performance was not good. That is why I applied this ReLU activation function.
Okay. And which hyperparameters you have selected, like filter size or number of filters? How you have decided that thing?
Actually, I have when I have coded through Python. I have filters. I have identified. Different filters, different types of filters, or number of filters I have varied. But in that when I applied 38 filters for the layers, I have got the better result. That is why this.
Okay, and have you handled the overfitting issue of this architecture?
Yes, sir. For overfitting issue was very higher. That is why I have used the optimization SMA for minimizing the overfitting.
Okay. Okay, ma'am. Good work. Keep it up.
Okay, thank you, ma'am.
Thank you for your presentation, ma'am. Now moving on to our next presenter, I would like to call upon Sir Pawan Kumar to present his paper on the title Dynamic Stock Price Forecasting Using Machine Learning and Real-Time Data Integration. Do we have you here with us, sir?
Yes, sir. Hello.
Yes, sir, you're audible. You may start presenting your screen.
Okay, sir. My screen is visible, sir.
Yes, sir,
Hello.
your screen is visible.
And am I audible, sir?
Yes, sir.
Thank you, sir, and thank you, ma'am, for giving me such an opportunity to present myself. I will talk about topic is dynamic stock price forecasting using machine learning and real-time data integration. Actually, I have developed an algorithm, or you can say I have developed a model to predict stock price prediction. Basically, it is very popular in the today today's market. There are so many applications available to predict the stock price. So, but I have implemented such new things. So I can explain it in brief. My topic is dynamic stock price prediction using machine learning and real-time data integration. And my team members are Anand Gupta, me, Prince Singh, Priyavat Kumar, and my guide or mentor is Dr. Parampreet Kaur. It is totally, pardon, sir. Uh, uh, Wait a minute. Yeah, thanks. Earlier, traditional stock forecasting methods failed to capture complex market dynamics. Investors need a reliable maximum model leveraging real-time data and machine learning. Because in stock market, it is very critical to predict the actual price because in the real market, actual money involves. So there is no chance of any error. So for this, I have used four models: LSTM, long short term memory, SDR, support vector multiplier, and also I have used decision tree, random forest. But I have used LSTM because it gives better result, better performance, and it gives highest prediction. So here we use multiple algorithm, but the least margin of error is given by LSTM. As I said, TCS stock data set was used to test algorithms such as support vector regression, decision tree, random forest, long short term method. Out of the algorithm, LSTM gave 96% success accuracy, whereas SPR gave the least one is 77% success accuracy. Objective of the project. I have developed a stock price prediction system where we can predict actual stock price, and I have used many ML algorithms like LSTM, long short term memory, SPR, support vector regression, decision tree, and random forest. I have used real-time data, and also I have used many performance metrics like R square, MAE, mean of shoot error, RMSE, root mean square error to predict the performance. The goal of the project is actually the main objective of the project is enhance the dynamic, accurate, real-time stock price prediction system, utilize state of the art machine learning and deep learning techniques. Problem complexity. Stock market prediction is highly complicated and volatile, driven by complex nonlinear relationship and external factors. And my feature of the scope is bridge the gap between theoretical models we have used earlier and real world applications. Use long-term historical data of TCS from 2010 to till today. And I have used actually four ML algorithms. First one is LSTM, long short term memory. it is based on time series data, and it actually gives better results, and it actually gives almost the actual prediction, and it's actually learns from historical data and remembers patterns from a for a period. Excellent for predicting stock prices. Good fit for time sequence data such as daily closing stock prices or trends. Accuracy I have got is 96%. And the second one, another second one I have used support vector regression. It is actually an ML algorithm which attempts to look at the baseline or curve that describes the data, capable of predicting when data is not linear. Accuracy it gives is 77%. And the next one is decision tree. Decides by formulating simple yes or no less than queries on the data. Simple to interpret but can be mislead by overly complex data. Accuracy it gives it 36%. Decision tree is actually you can say it is it is a simple version of the random forest, and it can actually lead to overfitting. But the other model I have used is random forest. Forest is actually a collection of decision tree which where I have used many decision tree, and it does not lead to overfitting. So as I mentioned in the PPT, random forest assemble decision tree for better and more stable prediction, performs well on the log sparse data, and prevents overfitting. Random forest gives accuracy of 92%. Here I mentioned all the accuracy I have got by using different ML algorithms. That is, LSTM gives 96%, SVR gives 77%, and decision tree gives 86%, and random forest gives 92%. The main questions is is why LSTM is the best algorithm, and why LSTM gives the best performance, and why and why I consider why I consider LSTM is the best algorithm I have ever used. Because the reason is it handles time series data. It's actually based on time series data. LSTM works well with time-based stock data like prices over multiple days. Remembers long-term patterns. It is one of the most important features of the LSTM, that is remembers long-term patterns. It had memory cell which actually store or remembers the patterns, which can be used for the next prediction. So it saves time, and that's why it is very fast and reliable. It can remember important past values while predicting new ones. And also, it is giving the accuracy of 96%. LSTM gave the most accurate results compared to the other model. And it is also and it also performs well in volatility, no matter how large the data set is and how fast the market is going. It adapts better to sudden changes in stock market trends, and it has also lowest errors. It has the smallest difference between real and predicted pricing. This is the workflow diagram. Firstly, I have downloaded the data set. The unique feature of my algorithm and my research paper is I have not used a stationary data set or fixed data set. I have used dynamic data set. For this, I have used a library called Wi-Fi, a library or API called Yahoo Finance. By using the Yahoo Finance API, I can use the real-time data set without need to download the whole data set, because stock price data set is a very large data set, and it can I need a lot of space to store that. So I have used Yahoo Finance API so that I can fetch any stocks data from directly by using Yahoo Finance API. And so after that, I have pre-processed my data set by using data processing.
This is a gentle reminder that 9 minutes have been completed.
Okay, sir. So I have used data processing to remove errors, and also I removed irregularities in the data set, like null values, missing values, and any other error in the data set. After that, I have used technical indicator to show the performance and show the predictions, and also yeah, and here after that I have used data set splitting. Data set splitting, I have divided my data set into two parts. First one is training part, and second one is testing part. For training part, I have taken 70% of data, and for testing part I have taken 30% of the data. And after that, I have trained my model, and for training my models, I have used good algorithms, as I mentioned, LSTM, SPR, decision tree, and random forest. After that, I have compared my prediction with the actual price, and I have go and
Sir,
I
you have exceeded the 10-minute time limit. Kindly conclude the presentation.
okay, sir, okay. So here is my output screenshot, and I have taken 100 days of data, and this is the screenshots. And finally, the final conclusion, I have used LSTM, which integrates real-time data, and sentiments is providing dynamic prediction of future stock prices. And I have used dynamic data sets for uh, for uh, for predicting the stock prices, and which is actually far better than the using the stationary data set. So and also comparability models makes the results more robust and helps to make more intelligent database investment decision in financial markets. So by using this model, I can easily predict the best actual prediction of any stock prices. Thank you, sir.
Thank you for your presentation, sir. Are there any questions?
Yes, Mr. Pawan Kumar, it was good presentation. You
Thank you,
used a
ma'am.
good approach of combining stocking and the machine learning.
Yes, ma'am.
In one of the slide, you have mentioned that you have used the combination of training testing percentage like 70-30. Now,
Yes,
why you
ma'am.
chosen this combination? Because you can use different variations like 80-20, 50-50. Have you tried all combinations or just you have used 70-30?
No, ma'am. I have used three companies. First, I have used 80-20, and after that, I have used 20-30, and after that, I have used 60-40. I have increased 10% to the testing part from 20% to 30% because because we are dealing with the real market. So model can be so powerful so that if I provide less training data, still it can actually predict the better prediction. That's why I consider 20-30 ratio.
Okay. In the further evaluation, along with this training testing percent variation, you can use one more testing also that is called as a cross-fold variation. So if you are using training testing variation and cross-folding, then it would be good combination. It would be grateful for getting the good results. Instead of focusing on one method only, you can use combination of different methods.
Yes, ma'am. I can use. You were actually telling that I should use a combination of different method like ensembling method. So I can use that, but but I want to implement deep learning uh, in this model. That's why I have not gone for ensembling method or combination of different methods because because stock price data is based on time series data, and LSTM performs very well for the time series data. So there is no need to combining more than one models because LSTM is more than enough to predict the stock prices like data.
Okay, does your model adopt new patterns in the data?
Yes, ma'am. If I so if there is any changes in the real market, so it can easily adopt the new patterns or any change happen in the market.
Okay, good.
Thank you.
Thank you for your presentation, sir. Now
Thank
moving
you,
on to
sir.
our next presenter, I would like to call upon Sir Samarveer More to present his paper titled Efficient Information Extraction from Large PDFs Using Retrieval Augmented Generation and Large Language Models. Do we have you here with us, sir?
Yes, should I share? I can begin the presentation.
Yes, sir. You may present your
Yes.
screen.
Is my screen visible?
Yes, sir. Your screen is visible.
Okay. We can start.
Yes, sir.
Hello, Prathamesh. Hello, Prathamesh, you are not audible. Hello.
Hello. Am I audible?
Yeah, yeah, not audible. You can start.
Sorry. Good afternoon, everyone. We are pleased to present our research work titled Efficient Information Extraction from Large PDFs using RAG and LLM. In academic and scientific community, vast amounts of the valuable information is stored in the unstructured PDF documents. However, navigating and extracting precious information from these documents becomes a complex task due to inefficiency of the traditional search techniques. Although modern large language models like ChatGPT have improved the semantic search capabilities, they are hindered by the content length limitation and the token constraints. So, this research aims to address this challenge by processing a robust web solution that leverages a retrieval augment generation in conjunction with the powerful LLMs. Our approach ensures context-aware, accurate information retrieval from the large academic PDF while minimizing the computational overhead and response latency. Core problem of the research addresses is the inefficiency and inaccuracy in the extracting contextually relevant information from the large scale and the unstructured PDF documents. Yeah, so I will hand it over to the Samar.
So let's start. Am I audible?
Yeah, you are
Yes, sir.
audible.
You're audible.
Okay. Let's start with the core objectives that have guided our project, which are firmly grounded in the latest advancements in the field. Our primary goal was to develop a web application employing retrieval augmented generation and large language models. So we are building on the foundational concepts of RAG, which was first introduced in 2020, which proved that combining pre-trained language models with external knowledge sources uh, used during that time was Wikipedia results in more accurate and factual responses. Our next objective was to enhance the extraction of information from large academic PDFs. Just as RAG has been adapted for specialized domains like biological questions with frameworks like BioRag or for course recommender systems, we are applying it to unique challenges of academic literature. Crucially, we aim to improve the speed and accuracy of of retrieving relevant data. To achieve this, we drew inspiration from innovative research like hypothetical document embeddings (HYDE), which refines retrieval even without labeled data, and multi-head RAG (MRAG), a novel framework designed to better handle complex multifaceted queries by improving retrieval accuracy. A significant part of our work involved model evaluation and comparison. This is essential to find the optimal balance between performance and resource uses for our specific applications. To ensure real world applicability, we focused on scalability, deployment, and performance testing because the application must be robust enough for practical use. Next, we'll go over the workflow overview of our solution. We start one with a PDF upload. It all begins with the user uploading a PDF document directly into our web application. Then we move on to text extraction, where once uploaded, the system gets to work, where we use a parsing library such as parsing library to extract all the raw text data from the PDF document. And then we move on to embedding generation, where the extracted text is passed through a llama model to convert the text into numerical representation known as vector embeddings. These embeddings capture the semantic meaning of the text. Then we move on to storing the embeddings, where these generated embeddings are then stored in a Postgres database, where we use the PG vector extension, which is specifically designed for efficient similarity searches on vector data. Then we move on to another one of the important steps, which is information retrieval, where a user asks a question, we perform a vector-based search on the stored embeddings. This allowed us to retrieve the most relevant sections of the PDF that are semantically related to the user's queries. And finally, the last step, which is the response generation, where our llama model, which is the augmented generation part of the RAG, this model uses the relevant context to generate a precise and informed answer to the user's query. We'll now move on to the system architecture.
Hello, am I audible? Yeah. So, hello, Samar. Can you just make that two of the slides are visible at the same time? Just zoom out a bit so I just explain properly. So starting with the system architecture, as you can see, the user provides two things that are first is documents and the second one is query, right? So the documents are processed via parsing. Then the parsed data is chunked into the chunking size that is given as a hyperparameter. It could be, for us, it was 2K. So every chunk will have 2K tokens in it. Now we generate embeddings using the embedder that is provided by Llama 3.2 1 billion model. Now we proceed to indexing them and storing them in a vector DB. So indexing them properly according to the file name and the chunks that are stored with it. Then when they're mapped, they're pushed into the vector database, that is PG vector, and the vector database is hosted on the Docker container, right? So now the query further process is also generated embeddings, which is of the same dimension, right? So now we perform a vector search, that is a cosine similarity search between the vector database and the user query embeddings, and we get the retrieved chunks. It could be 4 documents, it could be 10 documents. It's depending on your token limit for the given LLM. We can tune this parameter also, and we then re-rank these retrieved chunks also to determine their similarity and their context depending on the embeddings. Let's say there are 10 chunks, but the 10th one is more related to the query that user has provided. Then re-ranked chunks are provided to the prompt and the query along with it to the LLM to get a response. So in this, there are 4 steps. Can you just zoom into the methodology now, Sumar? Hello. So first first step, as I mentioned, it's the ingestion. That is, we upload the document, then chunking happens, then embedding creation, convert chunk into vector embeddings and store it in the vector DB, PG vector DB. Then the second step is retrieval. Then we perform query submission by the user. Then query embedding is generated. Initial retrieval generated. It uses the query embeddings to search vector database and retrieve relevant chunks based on similarities measures. As for example, we use cosine similarity. There are other similarity measures also. And now the third step, that is augmentation. That is re-ranking the retrieved chunks and reorder them based on their relevance to the query. So depending on their relevance to the user given query, they will be re-ranked and given to the LLM as a context. Then contextual enhancement. Combine the top rank chunks with the user query to provide richer context. And the final step is the generation. So for generation, we use again Llama 3.2 1 billion model, also hosted on another Docker container. And this whole thing was running locally for testing and for testing and performance measures. So contextual query formation, given user query plus context from the RAG, LLM processing, feed the combined query and context into the large language model. So when the context plus the query is provided to the LLM, the results are generated, and those results generated are specifically context aware, and there are no hallucinations as such, even though we used a very small parameter model, that is just 1 billion parameters model. Then the next step was methodology that was involved in application development. Can just scroll. So for development, we preferred local testing and verify the RAG components. are working properly or not. Then integration, then connect the RAG app with the Streamlit app for user UI and web deployment. And then deployment, we set up a server on Docker, so that will do all the performance, and all three containers will work simultaneously. And then the user interface, that will be Streamlit application, like similar to the LLMs that we see on the web, for a better user experience. Can just scroll to results. Yeah, I'll hand it over to Samar for the further steps.
So in the results, you can, as you mentioned in the system architecture, we are using chunks. So to manage a large document efficiently, we first split them into smaller chunks. This slide shows a log from our system during this process. As you can see from the info and debug messages, the system is loading documents into a knowledge base and creating a collection. The upserted document lines show individual chunks being processed. For instance, chunk 1 has a chunk size of 2097 characters and chunk 2 has a size of 2602. The chunking strategy is essential for the embedding model to process the text effectively and for retrieval of the system to find highly specific pieces of information. Next, we'll move on to the UI. So here you can see a screenshot of our user interface. On the left hand side, the user can select the model which they wish to use, add a URL, or drag and drop the PDF files directly. Below that, you can see the documents that have already been processed and that are ready for querying. The main windows on the right side is the chat interface. It starts with a welcome message with some example prompts. And that is it about the UI. Next in the results, you'll see our chunking and embedding creation and loading here, where the table shows the performance of different Llama models when creating vector embeddings. For an
So
average
this is a gentle reminder that 9 minutes have been completed.
Yes. So chunking, creation and loading. Our average size, as you saw, was 2000 chunks. So we tested according to that. The Llama 1 billion model is extremely fast and takes less than 0.5 seconds, while the larger Llama model takes a bit longer, between 1 to 3 seconds. Because the Llama 70 billion model requires significantly higher computational power, we didn't get to test this because we are doing local testing. Next, we'll move on to actually the hardware impact. So on the high end, i7 with 32 gigabytes of RAM and an RTX 4060, performance is excellent, so it takes about less than a second. With mid-range Ryzen 7, 16 GB of RAM and a GTX 1650, creation still takes less than 3 seconds, the embedding creation, but the response generation is 16 seconds. This is still kind of usable. While on the lower end with the Ryzen 5 with 8 GB of RAM and RTX 3050, we see a significant performance hit where embedding creation jumps to 25 seconds and the response generation takes more than 2 minutes. This clearly shows that both the GPU for parallel processing and sufficient RAM are critical for achieving a good performance in RAG applications. Thank you.
I would like to add a point. Can you go back to the UI section? Hello.
Yes.
Just a final note. Yeah. So basically, when a user uploads their document, that is stored in the chat, and the chat will be continue with its state. So you can upload the document once, and you can fetch as many as you can fire as many queries as you can. You don't need to upload the document more times. And then the chat is also stored in the database. Those are mapped with the user IDs and the chat IDs. Yeah, thank you.
Thank you for your presentation, sir. Do we have any questions?
Okay, all of you are of UG students.
Yes.
Yeah.
Okay. So during your explanation, you have mentioned about the RAG application, RAG.
Yeah.
So how this improve the information which is extracted as compared to the standard LM approaches? Means
Samar,
how
would you
this
like to
RAG?
explain? Okay.
Yeah.
Yeah. So,
do you want to take the explanation or should I?
Yeah, I'll explain. Okay. So basically, when you want to run a LLM, large language model on your system, right? So you either need to pick a smaller model, or you need to go with larger models, but they will not run at your system, right? So basically, while the information that they are trained with are very less compared to your requirements. Let's say I want to have a query on a specific book that is provided by my university, right? But that is not included in any of the LLMs and all that during the training testing. So when I fire the same query to ChatGPT, let's say, which has a very large training database, but he doesn't know about my book, right? So basically, so the responses that are generated by GPT, they are not contextual aware by my book that I want to get the answers from. So basically, so when I upload my own PDF and I upload my own documents, so the responses that are generated, that are contextually aware with the documents that I specifically provided. So for example, during the testing, what we did was the Llama 3.2 billion model, right? That it is not it is really not aware of the language that is used for compiler design. Let's say we used which was the language number, do you remember? Okay, fine. So another example I will say, yeah, history of Linux, the example that we are given in the result section, right? So we asked the same thing for without the documents given to the GPT, given to the model. So it did not give any results, it hallucinated, and it provided something else. So when we give the documents and all the retrieval and retrieved chunks were relevant to the query, so the answer generated was perfectly matching with the one given in the document itself.
Okay, you must have tested your application with different sizes of PDFs. So, up to what extent your PDF can have the size?
Yeah, so hello, am I audible? Hello.
Yeah,
Yes,
you're
yes.
audible.
Yeah, so basically we tested with two books of 1000 pages each, right? And the data, the time it takes for generating the embeddings, that will be higher. That's it. Once you fire the query, the vector retrieval is very fast, and the retrieved chunks are directly sent to the LLM as context. So the time and the, you can say, generation time and the embedding time, it depends on embedding time, it depends on the length of documents and length of context, and the generation time, it depends on the model that you're using and your system configurations. That's it. So you can fire maybe 10,000 pages of document also, that will only take more time for embedding, but the retrieval is faster anyways.
Okay. So, have you used any special pre-processing techniques to clean the PDFs, or it was not required?
Yeah, so during parsing, right, so we had to use stemming and stemming, that is for removing the grammar and all, right? And for we also used lemmatization during the process.
Okay, can you extend this approach for the documents beyond PDFs like scanned images or handwritten notes like that?
Yeah,
So
that was given in the future of reference. That is not in the PPT itself. So basically, we in the future reference we had mentioned that we would like to extend this approach for tables, for OCR images, and for PDFs that are not OCR. Like you can't copy paste from some PDFs, right, that are not OCR PDFs. So we have to perform OCR and then extract the text from it.
So most, like in your question, we are still dealing with text here. So in our future, like you mentioned, if you want to do handwritten notes and non-OCR PDFs, those are essentially images which
Yes.
we are going to be parsing. So that will go into natural language processing and other uh, areas which you have not yet integrated into our system. So that is still future work.
Yeah. Okay. Okay. Good presentation. Good work.
Thank you.
Yeah, thank you.
Thank you for your presentation, sir. Now moving on to our next presenter, I would like to call upon Sir Rahul to present his paper titled Enhancing the Performance of sorry, Enhancing the Performance of Wireless Sensor Networks through AODB Protocol in Wireless Mesh Network. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward to the next presenter. I would like to call upon Sir Pranav to present his paper titled Forecasting Stock Market Prices with Long Short-Term Memory, LSTM Networks. Do we have you here with us, sir?
Yes, sir, I'm available.
Yes, sir, you're audible. You may start presenting your screen.
So, my name is Pranav Mehta. I'm presenting my research paper based on forecasting stock market prices with LSTM networks. This the team members' name are Pranav Mittal, Krish Tyagi, Prerna, Nikhil Pawar, and Dhruv Bansal. We worked on this research based on the LSTM. There are 5 table of contents: introduction, proposed work, results, conclusion, and references. Now coming to the introduction part of our research, we know the basic of prediction that stock market predictions aids in investment decisions and risk analysis, but they are not much accurate because of investors segments and mood changes due to the affections of company values and company results. So the challenges we faced in predictions in stock market are influenced by various factors like assumed linearity and stationarity that are rarely applicable. LSTM networks handle non-linear and non-stationary data effectively. That is strong in capturing long-term dependencies and maintaining sequence information. Basically, LSTM helps in to predict on a large data sets and to rely on the hello, my voice is audible.
Yes, sir, your voice is audible.
So LSTM networks helps to predict data for large data sets and it overpass the ANN and CNN results. Basically, the traditional methods we use in a prediction, that is ARIMA and linear regression, that fail in dynamic markets and dynamic real-time prices. That results are limited to linear relationships and stationary data assumptions. But the deep learning and with the combination of LSTM networks, we can rely on more capable large data sets predictions and can do various graphs visualizations based on the statistics featureization of the key aspects of the company and the stock market price values. Our proposed work is basically based on the collection of data from the Python by Finance library that is based on Kokomo second model, that is already featured data we extract from that, pre-process it based on our LSTM networks and utilize it for it graph visualizations and few statistics and suggestions. We make use of activation function ReLU that is helpful to activate our LSTM networks, and the basically we use averaging of moving prices of the stocks. Here you can see we can enter the stock symbol and start date and end date of the stock means data for to extract, and then the model extract the data based on few features like low cost, high cost, uh, opening price, closing price, and profits and revenues. The processing techniques. Then we come on the visualization part of our research work, that is original versus predicted price based on RMSC, root mean square error method, and mean absolute error method. We make the use of 50 e-shops and basically on the 100 50 e-shops, the price versus moving averages are shown based on the difference between the predicted values and the moving averages of the actual values. The real prices are shown in continuous lines, and that reflects the actual market movements of the entire period in questions, and the prices with the colored lines, which is the output of the LSTM model, gives some historical data. The price trends are based on our simple moving averages and the exponential moving averages that show the price line and the moving average line, a signal to buy given when the price line goes up and rises above the moving average line, and while the moving average line is sloping up and inclined downwards, a sell signal to give when the price line sinks below the moving average line. This helps the person to devise strategies based on past data and present situations. Now we show some stock statistics and suggestions based on our feature extraction from the data sets that we extract from Wire Finance, based on the through which we suggest the average closing price, while volatility of the stock, and the suggestion to whether to buy the stock or to hold for some time to view and then go for it. After that, we examined the application of LSTM or deep learning in stock price prediction and demonstrated that they are better than conventional feed forward methods. The results suggest that structure of LSTM, which is mean for temporarily ordered and long range data, works very well to capture the dynamic and volatile nature of financial time series data. The findings prove the effectiveness of the LSTM model of reducing the prediction errors and showed its benefits in stock price forecasting in a more developed way and than other methods. Then we move on to the conclusion that LSTM outperforms the traditional feed-forward methods in predicting stock prices, and the structured design of LSTM networks captures the volatile nature of financial data effectively than other ANN and CNN networks. Implications of future research are that future models may include external features like financial news and social media sentiments, which will help to predict the exact market strategies which to whether to hold or whether to sell or buy the stock, or expanding models to predict multiple stock enhances overall market understandings based on our multiple situations. Then we use some references based on books and previous research work.
Okay, is it over, Pranav?
Yes, ma'am.
Okay, during your presentation, you explained that for pre-processing, you have used min-max scaling. So, is there any specific reason that why you have chosen this as other normalization techniques are available like Z-score and that?
Ma'am, can you repeat, please?
In your one of the slides, you have mentioned that after data collection, you have used pre-processing, right?
Not, ma'am. I have not done pre-processing. Actually, I have extracted the pre-processed data only from the Finance library that is uses Como second model. I use
Okay,
pre-processed data.
okay, but in your one of the slides, you have mentioned that step one was your data collection, step two was pre-processing, and in that min-max scaling was used. Okay. Why you have chosen LSTM only as simple? Some simpler models are also available, like linear regression, ARIMA, like this.
Actually, ma'am, linear regression and ARIMA fails when we apply them on real prices. Real prices actually fluctuate very fast, and their difference between them is quite enough big. So they fail on that time, and LSTM works on large data sets. They works for small data sets.
Okay. And have you handled the case like if there is some missing data in the collected data set, like missing
It,
data or null values?
yes, ma'am.
Okay, good. Keep it up.
Thank you for your presentation, sir.
Thank you.
Now moving on to our next presenter, I would like to call upon Ma'am Komal to present a paper titled Knowledge Pilot, Pioneering First One-Bit LLM for University Student Support. Do we have you here with us, ma'am?
Hi, sir. I am Vivek Nikam and I'll be presenting this paper as I am the co-author.
Okay, sir. You may start presenting your screen, sir.
Sure. Is the screen visible?
Yes, sir.
So I'll be presenting our research paper on Knowledge Pilot, which is our one-bit LLM which we pre-trained. So we have titled it as Knowledge Pilot Pioneering First One-Bit LLM for University Student Support. And we are the team of 5. These are the contents that we'll be presenting: problem statement, objectives, literature review, system architecture, methodology, and conclusion. So, talking about the problem statement, in universities, what happens when teachers actually teach particular things, they expect in exams student write the answers that were related to their teaching. And if someone like don't attend the classes or misses some lectures, he won't be able to write those answers to those specific things. So he'll try to look it in Google or ChatGPT and will get general answers and write it in the exam and didn't get much marks for that, as the teacher expects something that has been taught by him or her. So for that, we have made the chatbot which will be trained on specific data from our university. And for that, we have used one bit technique, which will be making it faster and less resource will be used for computation. And on low power devices also, these things, this chatbot will be efficiently running. So this was it. Then goals were like pre-training. We took Llama 3.2 and pre-trained it using one-bit technique. Then we, for retrieval, we created one markdown converter, and It takes PDF files, Word documents, and PPTs and converts them into Markdown files. Then we create dataset using dataset converter and feed it to our model. And we also have interface for admin as well as for students to log in and search for that specific topic that they want to study. So we referred these papers for developing this and creating our research. So this was the main paper which we referred, the era of 1-bit LLMs. Here they have mentioned about the BitNet B158, and we have done something similar to that. And this was the second and emulator for fine-tuning large language models using small language models. And okay, PDF data extractor was also there for Markdown converter. And from questions to insightful answers, building an informed chatbot for university resources. So coming on Markdown converter, which takes files and converts them into simple Markdown files, which will be easier for creating dataset and feeding it to model instead of directly feeding it to the model. So we have done this where the file has to be selected, it will be extracted, and after pre-processing, a markdown will be generated. And that markdown has to be passed to our dataset converter where that file will be selected. It will be passed and data points will be created. And at the end, a dataset will be created that will be used for pre-training or fine-tuning the model by admin from the interface. This is the basic system architecture where that dataset will be loaded, then it will be tokenized and normal text will be converted into tokens. Then embeddings will be created where dense vector DB will be created, and in transformer relationships will be established. And in bitnet conversion, actually the 1-bit technique plays the part where we have converted the 32-bit float values to 1 bit, means 1.58 bit, where all the values will be represented in ternary weights like -1, 0, or 1. And based on that, our model will be fetching the outputs. So this was it. And methodology was this simple. Idea planning, development of pre-processing, where the markdown generator and dataset generator came, and then pre-trained our model using those data sets, then fine-tuned and deployed on Hugging Face and user interface. Yes, it is there. These are the tech that we have used. For front end, we have React. At the back end, we have Python. Database was used, that was SQLite, and Django was used for it. And Google Colab was used for pre-training, and we have deployed it on Hugging Face. Okay. So yeah, we have successfully trained 1-bit LLM, and it was impactful during our academic semesters. We also presented it in our college, and yeah, it was successful for us. Thank you.
Thank you for your presentation, sir. Are there any questions?
Yes. In your project, you have used the concept of embedding also. So why it is important after tokenization? Can you skip that step?
Tokenization, after tokenization, it has to be clubbed in a DB, and to reach the next step, like understanding the relationships, it has to be in a structured format. So that we need embedding.
Okay, means skipping won't work in this case. In this architecture, this was specific for the application of student support, like for students.
Yes, for university.
So, can it be used as a general purpose application, or some
Yes.
modifications will be
Yes,
required?
yes, ma'am. It depends upon the file or the data that you are feeding, right? We actually use the Constitution of India as well while testing, and it was able to convert it into Markdown, and all the Constitution related answers were also given by our model. And if we ask something out of the context, like if I'll ask who is SRK, like then it will simply tell that this doesn't belong to the context. Please refer the docs for the pre-trained things. We can do it. It depends on the files that you are using.
Okay. In an architecture, you have used a transformer block also.
Huh.
Can it be used for long text dependencies? Can it handle long text dependencies?
Long text dependencies means large size are you talking about?
Yeah, large context.
Ma'am, we didn't actually train or tested it yet, but it should, I think. We have actually deployed it on Hugging Face, so it can, I guess, handle it because at the back end, it has Llama 3.2.
Okay. Okay, good.
Okay, ma'am.
Good work.
Thank you for your presentation, sir.
Yes, sir. Thank you.
Now moving on to our next presenter, I would like to call upon Sir Aditya to present his paper titled NutriScan, a Python-based barcode scanner for ingredient analysis and personalized health warnings. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we will be moving forward with the next presenter. Next, I would like to call upon Ma'am Krupa to present a paper titled Pedestrian Trajectory Prediction using Deep Learning, a CNN LSTM approach. Do we have you here with us, ma'am?
Yes, I am Aishwarya. I'll be presenting instead of Krupa.
Okay, ma'am. You may start presenting your screen, ma'am.
Okay. Full screen for me. Oh shit. Share. Can you see my screen?
Yes, ma'am. Your screen is visible.
Basically our model is about integrating CNN integrating YOLO and LSTM pedestrian in deep learning model. We have used YOLO, which also comes under CNN. Which is also a CNN. So our guide is Evangeline, and my group mates are Krupa. I am Aishwarya, and Lasya Pemana is third member. So moving on to the introduction, where has the cities transformed into smarter and more connected environments to ensuring pedestrian safety has become a critical challenge. With growing interaction between vehicles and pedestrian environments, there is immediate solution that can prevent accidents and provide pedestrian prevent pedestrians from accidents. So to prevent pedestrians, to prevent the accidents from happening, we have used a deep learning based approach through real-time recognition, object detection, and trajectory prediction. According to World Health Organization, there are over 270,000 pedestrians who are losing their lives in road accidents every day. So our model delivers a precise real-time insights into pedestrian movements and pedestrian movements. So this enables the development in effective safety measures and significantly reducing the accident. So our solution demonstrate the power of deep learning, deep learning in urban environments where technology can actually protect human life. So we have taken problem statement where we have addressed the challenge of pedestrian safety by developing a deep learning model for real-time recognition of actions and accurate trajectory prediction for crucially improving the safety in smart environments.
Hello, ma'am.
Are there any questions?
Yeah, if you have any questions, you can let us know. We all
Okay.
have questions, yeah.
Does your dataset include some crowded or dynamic environments also?
For crowded, we have used this two data sets, ma'am. This crowded, one is crowded data set, ma'am. The second one that we have used is near our hostel. Small, very less number of people are there.
So for the first dataset, we have a lot of crowd. We have a lot of crowd moving around. But as for the second data set, there are limited people, and from the up angle, so we can see what is the how we get the results.
And
Okay, so does your model can handle some unpredictable behavior, or if there are sudden direction changes in the data set or in the movements like that?
So our model can predict where if the person changes their angle suddenly, it will be able to predict if that the angle has changed. And the future scope is we have a lot of future scope in it because we just tried to do a trial if our model is working or not, and it's working. But there are a lot of future perspective, like you said right now.
Okay, so could this approach be adopted for other types like trajectory prediction or like vehicles or drones? Can it be applicable for these kind of applications?
Yes, it might be applicable, but we haven't fed those data set. We just fed human data set. But yes, that model prediction can be done from our model that we created from UNO and LSTM.
Okay, okay, ठीक है, good work.
Thank you, ma'am.
thank you.
Thank you for your presentation, ma'am. Now moving on to our next presenter, I would like to call upon Ma'am Nisha to present a paper titled Robotic Facial Profile Classification and Recognition Using Conventional Neural Network. Do we have you here with us, ma'am?
Thank you so much, sir. Thank you so much, ICT team and GR Foundation. Now I'm sharing my screen.
Yes, ma'am.
I hope screen is visible to everyone.
Yes, ma'am.
My topic name is Robotic Facial Profile Classifications and Recognition Using Conventional Neural Network. First of all, a facial profile classification. Facial profile classification is a biometric analysis to categorize facial profiles into a different categories or classes. Our facial emotions is a biometric technology that analyzes different based on shapes and features. The conventional neural network is performed in a layer-based feed the input and show the output, feed the input in a image or video format and show the output 95% accuracy. It is used to verify the particular object features. Topic to be covered: abstract introduction, research methodology, challenges and limitation, future direction, result discussion, summary, and references. First of all, abstraction. This paper approach utilization conventional neural network to classify and recognition facial profile. The purpose system utilizes a significant CNN design to remove solid highlights from a facial profile taken after by the classification layer to recognition profile classes. And the accuracy is a classifications is a 95% and the approximations classification is a 92.5%. Facial recognition has many applications in security and identify verifications aim to improve the accuracy and facial profile classification. And the keyword is used: facial profile classification, facial expression analysis, and facial detections algorithm. Introduction is a new way to recognition and classify facial profile using a type of artificial intelligence. And artificial intelligence is a conventional neural network is a small part of artificial intelligence. It is used to verify the images. Facial profile classification and recognition has based on increasingly and extremely important in a various applications: security, observation, characters, and confirmation and control. First of all, character. Character is used to recognition the face individually and next to move the evaluating. Evaluating is a person like a person age, person, range. First of all, they're like a child grow up, and the range is a senior or junior. And next to move in a classify. Classify is the strongly classify and diverse into a facial group, and then move into a categories. Categories classify the expressions into a categories. Next is the research methodology. Research methodology, first of all, conventional neural network feed the input in a network, and then feed the input image. Conventional neural network subjected to the conventional layer filters the applied to a small regions of an image and exact features. The filters scan the image in both directions like a vertical or horizontal, performing a dot product at each position to generate features map, and then move to a features map. Features map the output of a conventional layer in a set of a feature map, which is represented the presence of specific features at a different location in a input image. These features maps are passed through the activation function, and then move to the subsampling. The features maps are then down samples using the techniques using a max pooling or average pooling. Reduce the spatial dimensions of the features map while retaining importance information. Next, move in the strong conventional. Strong conventional features maps are then feed into the another set of conventional layer, more complex features and exact. Then next move into a subsampling. The output of a second set of the conventional layer is against down sample to the further reduce the spatial dimensions. Then next show the next fully connected. Fully connected is the output of the conventional F sub sampling layer is filtered into the ones of the dimensions array and feed into the fully connected layer. This layer is used for the classification task. Next, to show the output. The final output of the network is the probability distributions over the different classes or continue value or depends on the task at the hand. And next is the method. First one is input. Accept first of all accept the an input, and then next apply the conventional layer, then an activation layer. Activation layer is occur, and then fully connected layer. The RELO is a fully connected layer, and then finally the softness classify the obtain the output and classify the prohibits. And next is challenges and limitations. We lighting, posing, and expressions, limited availability or profile spaces, data set, conceptual complexity, and memory requirement. The future direction is developing more robust CNN architecture for facial profile classification and recognition, exploring transfer learning and domain adoptions techniques, investigations, the use of the 3D facial data and profile facial recognition. And then next is result and discussion. First of all, reliability. Reliability show the able to correctly identify the person most of the time. Then next is robustness. Robustness should be able to handle different situation like someone who is wearing a cap and how to identify the face. Identify the face used to robustness and still able to identify the correctly. And next is the general ability. General ability refer to the well of the techniques. Technology can be applied for a different person and situation. It should be able to work well even when the face with the new and unfamiliar faces. And next is the strong classification and recognition. And the most of the important is a biometric algorithm. Biometric algorithm method is used to analyze the facial features and identify persons. So next is the summary. The facial profile classification and recognition utilization conventional neural system. The purpose framework utilized to profound CNN design and exit various highlights from facial profiles taken after the classification layer and profile classes. The classification is 95% and the affirmations is 92%. So next, this is my references. Thank you so much.
Thank you for your presentation, ma'am. Are there any questions?
Yes, Nisha, your work is good. I
Thank you
just
so
want
much.
to ask a few questions like can this model handle variations in the facial expressions?
Yes, ma'am. Used a conventional neural network algorithm is a biometric algorithm. First of all, biometric algorithm feed the input and then conventional neural network verify the facial expression and then show the output.
Okay, and suppose one scenario where you replace your ReLU function with some another activation function like sigmoid or tanh like this. So will it affect the model performance?
ReLU
If
function activations are 98% activations is I think good. So
okay, so if you are going for another, then it would decrease the accuracy of your model.
sorry, ma'am, I have no idea.
Okay, so you are tried only with ReLU function, not
Yes,
any
ma'am.
other.
Yes,
Okay.
ma'am.
Have you faced some issues like overfitting?
Yes, ma'am. Overfitting is features when you verify the features if wearing the cap and if wearing the mask and it's not possible to verify the features. So we use the technique for max pooling and sub max pooling. So it is easily to and 4% accurate the result.
Okay, Nisha, good.
Thank you so much, ma'am.
Thank you for your presentation, ma'am. Now moving
Thank
on to
you.
our next presenter. I would like to call again Sir Rahul to present his paper titled Enhancing the Performance of Wireless Sensor Networks through AODV Protocol in Wireless Mesh Network. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. I would like to call again Sir Aditya to present his paper titled NutriScan, a Python-based barcode scanner for ingredient analysis and personalized health warnings. Do we have you
Hello,
here?
can you hear me?
Yes, sir, Rahul. We can hear
This
you.
is Rahul. Yes. Okay.
Yes, sir. You may present your screen, sir.
You can start presentation?
Yes, sir.
Yes, please. We'll share my screen. Give me a second. Very good. Sir, is it visible?
Yes, sir. Your screen is visible.
Yeah, please. Thank you. Okay. So, good afternoon, everyone. My name is Dr. Rahul Pete. I'm working as an associate professor. Is it visible now? First slide?
Yes, sir.
Hello? Yeah, please. Thank you. So, my title is Enhancing the Wireless Sensor Network through AODV protocol in wireless mesh network. Why mesh network? That we will discuss in this particular upcoming presentation. So about this particular title, we will going to discuss all these things, aim and objectives, WSN, what exactly WSN, NS2 and all these things. So about the WSN, we know this is wireless sensor network, a platform where a node which is having a particularly transmission of wireless power media. Okay, either we can say that data or video or audio, whatever, from source to destination. Is there is some sort of compare data transmission rate with neighbor node itself. Neighbor node, the next node, because it cannot possible. Sometimes data has been sent from source to destination directly. So some sort of challenges we have. Okay, so we have to depute one like cluster head in a network. Okay, that cluster head have a energy. If this energy get reduced, so that cluster head cannot send the data. This is our problem statement. For that purpose, what we can do, we can assign a virtual cluster head. It means the cluster head have a highest energy. Virtual cluster head have also have a equal energy. But if the cluster head is going to reduce their energy, that time virtual cluster head take their decisions and start to send the data from source to destination inside the network or outside the network. So their applications, we can say that like environment monitoring, wireless sensor nodes different with different parameters, we can say, and that have a like a standard version of IEEE standard 802.15.4. So I can say that like this particular system is more reliable, more suitable, and it can be efficient packet processing. Packet is the data from source to destination traveling from in the form of packet itself. We can properly direct it towards a data flow itself. Network configuration is easy through this particular like system. So we see here we have a network, we have a user and a gateway. Inside the network itself, the data has been sent inside the network. So for that purpose is as we have a gateway will send the data inside the network, but inside the network there are multiple nodes, out of which some nodes have a highest energy will work as a cluster head. The cluster head will receive the data and send it to the other node which is available inside the network. So for that purpose, if the network is reducing their energy, so we can use the virtual cluster head. So consist a large amount of sensor node, multi-hop self-organizing is the thing, wireless communication, cooperative sensing, collections, data from cluster head to virtual cluster head or virtual cluster head to node itself, process and send to observe properly is again application of this particular system. We know about a wireless sensor network, infrastructureless, mobility, multi-hopping. And these are the particularly wireless sensor network applications are the characteristics we can say. So data collection at regular interval by the node, for the node, to the node itself. So data collection is regular. And then transfer data into the electrical signals or the binary signals, that is a issue, and that data should be reached at the destination. Complete packet should reach at the destination. So in that case, if the cluster head is going to reduce their energy, then it will be a problem for our network. So for that purpose, we have to design a sensor. We know about the sensor. It can be collect the data in a physical quantity and convert into the electrical quantity. Sensor node, which can sense the data completely, and it is available in a network to travel a data, any type of data, for example, temperature, humidity, pressure, any type of data, and the parameter. The parameter QoS parameter of this particular data is nothing but your, we can say that jitter, throughput, PDR, all these things. So we can like skip these things. We can just go to the point where we can concern about the proactive network and the reactive network. And by using this proactive and reactive combination of proactive and reactive, we can design our own system by using a hybrid network where we can use proactive and reactive network protocol and combine this particular protocol for our methodology. For that purpose, we have a survey of different papers through which we can understand everywhere they can assign a single cluster head, base station or cluster head. But if the cluster head is going to reduce their energy, that will be an issue. So for that purpose, we can deploy one more we can say that virtual cluster head is our algorithm. So these are the papers which we already studied, and we have a complete description about all these things, where we can identify the sensor. If the reducing of particular energy, then it will be a problem for that particular network. So the scope is, we can say that it is a large scope where we can identify the problem and optimizing the performance of a system. In addition, we can say that present routing protocol can extend that particular system and use a new application itself. And performance of current protocol algorithm can be evaluated and simulated in the form of different we can say the experimental result is our scope in this particular system. So although the performance from the protocols is promising, but efficiency, the data processing, addressing issues are the issues which will be a problem of this particular scenario that can be reduced for the 5G network and the higher data processing network. So this is again an energy efficient protocol which we already identified their key feature. These are the things which is we can discuss, as we have only 5 minutes, so we can just skip and we will go to the methodology. So our methodology, we can say that where we have a network. This is a network. We have different clusters. Okay, in which clusters there are particularly a cluster head, and each and every cluster network have their gateway address. So base station will send that particular data to the network through that particular gateway. That gateway will send the data to the particularly cluster head. But you can see, observe a pink dot. Pink dot is a single cluster head in each network. So that is one of the issue. So for that purpose, what we can do that we can just simulate that particular particularly network in the different form, network structure and protocol operation. Which type of protocol operation we have to perform and which type of network structure we have. So flat based network, then hierarchical based network, adaptive routing, such a type of routing schemes for WSN we have. And in a proactive, we know about that DSDB, AODB, DSR, these are the particularly a routing system. So by using reactive and proactive, we can going to design our own, where we can identify, we can just give you the solution on this particular network. We can just skip. Okay. So here we can see we have a network. This is a base station. This is a cluster here. So these are the network. If we need to send the data to any node in this particular network, so what happened? First of all, base station will send that data to the cluster head. Cluster head will send to the net destination, but through a particularly, we can say that nearby network or next home. It cannot sometimes possible to send complete data directly to the network. So it can be sent it through the nearby node. As we know that there are multiple algorithms we have in this particular network system. But the thing, whenever this particular network is distributed in a sub network, so cluster head are also going to distribute it, or cluster head are also a part of this particular network. But if that particular cluster head will get reduced their energy, so that will be a issue. For that purpose, what we can assign, we can do a cluster, that particular cluster head is a particular network head, but we can also assign one more cluster head, that is called as virtual cluster head or cluster virtual head, which is a point of contact with a base station itself. It
So
will
this is a gentle reminder. This is a
pardon?
gentle reminder that 9 minutes have been completed.
Yes, but thank you very much. So the virtual cluster head is going to like maintain the energy of cluster head itself. So the consumption of energy of a cluster head is get maintained. So these are the things. Here we can use some sort of routing protocol. We know very well about this routing protocol, and this flow of data, routing protocol data from source to destination at this we can see here. So these are the some results by using WSN, where we can identify the network, where we can distribute this particular network in a deployment of node as well as the distribution of a network. Then this distribution of network will identify the source and destination, where we can identify the cluster head and virtual cluster head itself through which we can like check the delay, jitter, throughput, energy, and other in a like packet delivery ratio. So I can just go to the like we also identify the delay versus time, energy versus time. These are the jitter versus time. So we can calculate this. This is the results message broadcasting window. Here we can identify parameters where parameters are DSR. Yes,
So you have
AODV.
exceeded the 10-minute time mark.
Yeah,
Kindly conclude the
yes,
presentation.
please. So we will get this particular result, improvement result. We can understand that the R hybrid protocol by using DSR and AODV is useful and good for the system, for the upcoming network itself. These are the complete results we identify. So this is from our end. These are the references that we use in our paper itself. And conclusion is the hybrid algorithm is useful for the further communication where we can reduce the energy of cluster head. Thank you very much. If you have any doubt or any question, please. Hello.
Okay, sir. It was good presentation. Can you tell me how scalable is this solution for larger networks or say smart city applications?
Yes, of course. See, larger network or smart city application, we can say that it can be again divided in a small clusters. Of course. So if the small clusters are being used, then the data processing is easy. First point. Second point, if the cluster head also depute one virtual cluster head, it means the main cluster head which use the data processing from source to destination or intra-network or inter-network, then it can maintain a long life solution, and it can maintain the energy up to the long lasting. So this is again a like good solution for the large network where we can use in application as an like smart city itself.
Okay. Have you faced any challenge in implementing or simulating AODV in this context?
No, not like that. But we will just comparing to DSR and AODV, and we can just implement both the things. DSR and AODV will get the results, and we can just identify the problem. On that particular problem, we work on the same, and we'll get the result of our own hybrid model.
Okay, sir. Good work.
Thank you. Thank you very much, ma'am.
Thank you for your presentation, sir. Now moving on to our next presenter, I would like to call again Sir Aditya to present his paper on the title NutriScan, a Python-based barcode scanner for ingredient analysis and personalized health warnings. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificate through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I also thank our session chair, Dr. Vaishali Rajput, for chairing the session. I would now like to request ma'am to share her thoughts and any feedback about the presentation for the session. Over to you, ma'am.
Okay, thank you, Ashutosh. And I would like to congratulate your whole team, organizing team, and all the participants for giving such a good presentations, meaningful presentation. I would like to specially mention one thing, that quality of work presented by everyone was very impressive, whether by PhD scholar or undergraduate students also. It is very good thing that UG students are doing such a good work under the guidance of their professors. Everyone showcased their good efforts, creativity, and depth. I wish good luck to everyone for the future contribution. Thank you all once again, and I wish you a wonderful continuation of this conference. Thank you, organizing team, and all the participants.
Thank you, ma'am. A token of appreciation to the chair on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you everyone for your valuable presence. Just before we end the session, I request you all to kindly switch on your camera for a quick snapshot of the virtual conference. Thank you all. Stay safe. Take care.